just, could you please confirm that you can see the presentation? Yeah.
Yes, we can see it, but
Okay.
in speaker's view.
Okay, let me try to.
So if you.
No?
Still in speaker's view.
Sorry for this. Let me try to share again. I don't know. Now maybe, yeah, because I don't know.
Now it's perfect.
Yeah.
Thank you.
Okay. Hopefully it works now. So thank you very much. I will now try to give you an overview on the innovations on renewable materials for the textile industry. But before starting, I would like to thank you for the invitation to be here and to thank TEX-BREIN Consortium for this invitation. So just a brief presentation of CITEF for those that don't know us. So we are the Technological Textile Institute in Portugal. We have three main core activities. We have the testing and product and process certification in our laboratories. So we do over 600 standards and that are available for testing the products, the textile products. We also have a department that is dedicated to high-level training and coaching. And we have the research and development, which is also one of the core activities of CITEF, and we are doing research in three main areas, I would say. So we have the sustainability, bio-based economy, and circular economy, also the development of more efficient processes, and also the digitalization of industry. Since textile is everywhere, as we used to say, we are very much market-oriented, and that is also because we have a very strong textile industry in Portugal. So we do research for several application markets. And we also have in the same group CITEF certification and CENTI that you probably also know. So before starting and introducing some examples of the work that we are developing at CITEF, there is a motivation, of course, and the motivation are the challenges that we are facing, that you also are all aware of it. But it is true, and in particular, in the moment that we are living now, it is true that we are facing a lot of challenges that can redirect the economy to a different level. One is the impact of the textile industry. So this is data from the World Economic Forum already from 2021. So they are probably not the most updated data. But it's true that the fashion industry is among the top 5, the most pollutant in the world. And it's also true, and all of us are aware, that is an industry that consumes a lot of water, a lot of energy, and a lot of chemical products. And as you also all are aware, we don't have production of raw materials in Europe. So most of the majority of the raw materials, and it's not only fibers, but also chemicals that we use in the textile industry are imported. And I would say that more than 95%. And this is a very high challenge, in particular in the changing economic world as we see now. Additionally, there are a lot of regulations, in particular these 16 regulations that are being addressed. So not only the digital product passport, the extended producer responsibility, but also banning of some chemicals and the revision of the REACH and the release of microplastics, for instance. So a lot of regulation that are posing limits to the use of some raw materials and to the need to develop alternative bio-based materials. So this is also an opportunity for the textile industry. So we look at this as an opportunity to engage and to look at the materials that we have available to develop new fibers and new chemicals for the textile industry. I would like to recall here the Priority Research Innovation Agenda from ETP that was released in 2024. And in particular, the first pillar where we should focus on the development of sustainable material and clean processes. And this is being also the work of CITEV for the past 10 years or more. And we have been focusing on this due to the challenges that I already mentioned. And in this core area at CITEV, where we call bioeconomy at textiles, is a very strong area of research. And in particular, I would like to highlight a project that we are coordinating, that was financed by the Recovery and Resilience Plan here in Portugal. It's a very big project. It's 71 million euros on funding. In reality, this project is a very big project that aggregates 58 different projects, and we have also 58 partners, not only from the textile value chain, but also from the agriculture, from the technology of information industries. So many different players that can play a significant role and change in the textile industry. This project is organized into 4 pillars and 9 dedicated work packages. And the idea of this project is to have a holistic vision of the textile industry, the textile value chain, and try to focus on how we can promote not only the use of biorenewable materials, but also a transition to a truly circular economy. And this is what I will show you some of examples of what we are doing today. So the first pillar is really dedicated to the development of new bio-based renewable materials, particularly fibers and chemicals. So we are exploring new fibers and nonwovens from forests, so from eucalyptus, cellulose, which is very strong here in Portugal, also in other countries, but here in Portugal, we have a very strong forest industry. We are focusing as well on bringing back to Europe and in particular to Portugal the cultures of hemp and linen that we were very strong in the past, but we lost the technologies to do this. Also using residues from agriculture like banana and pineapple leaves to extract new fibers. And finally, looking at all these residues that we have available from other industries and using industrial symbiosis to develop new dyes, new pigments, new functional ingredients, for instance, biopolymers like collagen, hydroxyapatite as an ingredient to remove odors, lignin that can also work as a color, to provide color, but also as a flame retardant or antimicrobial additive. So there's always this holistic vision, and we are focusing on promoting zero waste. So in every process that we use, we try to promote the reintroduction into the textile value chain as much as we can. In particular, I will focus now on some of the developments. So we will be installing 2 factories in Portugal to produce regenerated cellulose fibers. And this is a partnership that will be happening between a cellulose producer, Altri Group, and also investment from IQ, and in particular with the ionic technology. And they are installing capacity in Portugal to produce fibers, in particular lyocell, but especially fibers with special properties. So one of the core activities is using not only cellulose from eucalyptus, but also different cellulose sources. And by the different cellulose sources that we are exploring textile fibers like cotton residues from home textiles, for instance, like bed linen or towels. We are exploring bacterial cellulose as well. So together and combining them with this cellulose extracted from the wood of eucalyptus, we are developing these functionalized lyocell fibers. And in particular, we are focusing on antimicrobial, flame retardant, hydrophobic, but also traceability fibers. So as an example, we are introducing in the cellulose dope that I was showing in this example, we are introducing lignin, which is a residue from the paper industry itself. And lignin can provide flame retardant properties, but also hydrophobic and other properties. Additionally, we are introducing other biopolymers and ingredients to provide antimicrobial, and with the aim is to have fibers not only for conventional commodity textile products, but also for very special niche markets that we want to address. This is an example of the lignin fiber. So it has this brown color, and in the other image, you see the fluorescence of the fiber that was marked with a tracer for traceability during the value chain. Also nonwovens, because it's a very important application, a very important technical process for fibers that cannot be transformed back, cannot be recycled to produce new yarns. So when when the fibers are very small, we need to look at alternative materials. And nonwovens, and in particular nonwovens made of renewable materials like lyocell, like even combinations with hemp and other fibers, they can provide very interesting properties for very different applications, not only for technical textiles, but also even for fashion or even for construction, decoration, architectural applications. So we are exploring the development of alternative nonwovens that are made with renewable materials, and they are a bit biodegradable, but have important properties that can be addressed and can replace the typical nonwovens that are produced by synthetic fossil-based polymers. This is another example of the use of alternative natural fibers. So you see there pineapples and banana leaves. They are residues from the culture of these fruits, and we are extracting them to produce fibers. And the biggest challenge we had was to develop equipments to do the extraction. So manual extraction is, of course, not feasible, and we had a very strong effort on this project to develop equipments to be able to extract the fibers in a more conventional and a more advanced and optimized way. The same for hemp and linen. I'm showing here just a hemp culture, and you see an image of the culture from this year in the Alentejo region. So in hemp, we had to make all the way, and we started by selecting the most appropriate plants, the most appropriate species to our climate conditions, and also the soil conditions, optimizing all the process of growth. But in particular, a very strong effort is being placed on the degumming stage. So this is very important. It's typically performed on open air in the fields. And this is a way to have a lot of variability in the fibers. So we are making a strong effort on having more efficient process for degumming and more controllable, in a more controllable ways, using enzymatic processes as well. And also on developing equipment. So we have installing in this project also equipments in Portugal to produce fibers by using these hemp and linen, to produce yarns from hemp and linen fibers. Regarding the composites, and this is a very strong trend as well on developing composites for using bio-based renewable fibers as reinforcement. And we are exploring not only on prepegs, but also on reinforcing layers using nonwovens, but also UDs and also yarns and fabrics as reinforcement. And the application is mostly focused on this project for the automotive industry, because it's where we have the partners engaged in this consortium. And the idea of these bio-based composites is to have alternative materials with the same requirements that, of course, that are needed, but with more with lower CO2 footprint. And we are also exploring in parallel the recycling of these bio-based composites, and we have achieved quite interesting results where we can retrieve the fabric, for instance, that was used a reinforcement layer, And this fabric can be used without losing the mechanical properties, and we can reintroduce back into the value chain. And this was a strong result also from our project, in particular of the biocomposites. But I mentioned as well, we are not only focusing on new fibers and yarns for the textile industry, but also on developing new chemicals and dyes and additives. And for this, we are exploring three main processes. So physical processes where the main goal is just to prepare the residues to a certain, for instance, a certain size or certain conditions that they can be used directly without any further processing, but also exploring hydrolysis processes using sustainable and green chemistry approaches. And with this hydrolysis, we can retrieve polymers, for instance, bio-based polymers like collagen, which is one example, or other ingredients, and also using some of these residues as a carbon source for fermentation processes, and then achieve other ingredients, for instance, biosurfactants or dyes that we can achieve by fermentation. These are some of examples. I'm sorry because the legend is in Portuguese, but I will briefly explain what we have here. So in one example, so we have a towel, cotton towel that was treated with a plant residue. And this plant residue provides antifungal properties, so there's a way to avoid the humidity or odor that usually happens when we have a lot of humidity in the towels. And on the bottom, you see a wool fabric that was treated with lanolin. Lanolin is a byproduct of the wool industry, as you all know. So we changed this lanolin to give it surfactant properties and to give some moisture management properties to wool by combining with a very specific chemical treatment. In the middle, you see two examples produced in the same industry. These are they were already produced at industrial scale. And the first one is using the ashes from the biomass boiler that the company has. So they produce energy for their own processes using biomass boilers, and the ashes are processed, and they were used to do printing of linen products to use on home textiles, on our home textiles collection. And below is to use the wine pruning, but the same process by a conventional printing process, they were applied into this home textile collection. And the last two images, they show one example of a cork cotton yarn that was coated with cork residues and also with pine residues. And with this, we can produce different collections of home textiles, for instance. And below, a very specific space dyeing using olive trees for providing color and also antioxidant properties to these materials. Finally, I would like also to mention that we can also retrieve some materials on optimizing and the waste from the textile industry itself. So it's crucial that we really make the change for a truly circular textile industry. And this means that we need to develop new processes. It is also true, and you are also aware, that mechanical recycling is very limited due to the property of the yarns that we can achieve. So we need to make a strong effort on developing other recycling approaches, chemical processes, biotechnological processes, but also promoting the eco-design and eco-engineering and the upcycling, because one of the big limitations of the end-of-life scenarios is truly the sorting and the separation of the wastes. So regarding this, we are also making a strong effort in this project to develop more efficient solutions for sorting and separation of textiles. This is the schematic drawing of our pilot line that will be implemented until the end of this year here at CITEV. And in this sorting line, we are combining conventional technologies with sensors that are available, some sensors that we are developing, but in particular also with neural networks and artificial intelligence to really have an efficient sorting of the textiles. Additionally, we are also installing an automatic equipment to remove the hard parts. One of the most challenging limitations to the textile recycling is all the accessories, the buttons, the zippers, and all the labels and all the accessories. So this equipment is using a conventional cutting machine that is present in all the industry that do produce the prototype, the clothing. And we are using the visual and the cutting that is already available, combining with different sensors and softwares to do the recognition and algorithms to do the recognition of the accessories and to do the coating. And this is performed using robotic arms. So one robotic arm is placing the garment in the right position. The other is removing the accessories or the piece, depending on the case, from the cutting. And this is on a continuous way. So we're trying to also make this as a more efficient process and to try to improve the hard part removal. And additionally, and this is quite important, if we want to valorize, to do the upcycling, to valorize the recycled materials, we need to focus on pretreatments. And one of the most important is to remove the color. So by one side, we need to assure that we don't have any contamination. So we are using ozone technologies just to remove all the others and to assure that we don't have microbial contamination. But we are also using ozone technology to remove the color on fabrics. And this can be done at fabric level, but also at fiber. I have some examples there that you can see. And this is very important because if we remove the color, we have the possibility to reuse the fabric directly and re-dye or do printings or whatever. So we are not losing the raw material itself. Or at the fiber level, we can transform into a yarn that can be dyed and can go and don't have the limitation of being only gray, which is the typical color that we use when we combine different textile waste on mechanical recycling. So this process is being explored for 100% cotton, 100% polyester and woolens because are the most common substrate. And we are using only sustainable processes for this. So mechanical recycling, you are aware, we also are exploring mechanical recycling, of course, to produce new yarns, but also non-wovens, I already explained. This is one typical example where the mixture gives this gray color, but we are also focusing a lot on chemical and biochemical recycling. This is one example where we are using a fabric, 100% cotton fabric, but also with a mixture of elastane and using suitable pretreatments. We can not only remove the color, but also remove the metals, which are important for the subsequent step because we need to make the dissolution of the cellulose and we need to do a specific adjustment of the degree of polymerization and intrinsic viscosity. So all these pretreatments are crucial to have the cellulose ready for the dissolution steps. And as for the dissolution, we are exploring NNMEO for the lyocell process, but also ionic liquids and also dipiotetic solvents. And you can see there an example of a dope where we have being produced fibers by wet spinning, but also we could separate the elastane fraction. And instead of throwing away this elastane fraction, we were using as a reinforcement layer for a non-woven that we produce also by this process. So this is one example on when we have an holistic vision looking at all the materials that we have, we can truly promote their circularity and reintroduction back into the textile value chain. The other example, this is the difference where you see the color removal, you can see the difference before and after, so it's a quite efficient process. And as for the biotechnology processes, the main difference is the dissolution of cellulose, that we are using a combination of enzymes. And these are some examples of what we are exploring with this enzymatic process. Of course, producing man-made cellulosic fibers by wet spinning, using the pulp from textiles to be introduced back into the pilot line to produce the man-made cellulosic fibers. But we can dissolve further, and we can achieve reducing sugars that can be used either as a carbon source to produce, by fermentation, to produce, for instance, PHAs, which are bio-based polyesters, to produce dyes, to produce surfactants. And in this particular case, I show you there, we were using the reducing sugars to coat the yarns and to avoid the peeling that is very common also on mechanical recycling. And also, again, the recovery of elastane in this process. Again, you can see the change in the color, and this is the example of our pilot recycling line and the pilot reactors that we have to promote to produce these processes. And this is another example where we don't need to recycle, and this is mostly focused for pre-consumer textile waste. So there's always a huge amount of products, textile products, they don't leave even the storehouses, or they are not sold by any reason. And we can transform them by some eco-design and eco-engineering processes into new processes. So the process that we are exploring to remove the color, we can also remove the printings, for instance, and generate new products without generating new products. So and below you can see some examples where you see in one side the original product, and in the right side the treated product. That seems, in particular, the last one, the orange dress, where it seems a different product, but in reality we just have this color removal without changing the mechanical properties, of course, because the textile requirements are crucial for the industry, and we can achieve new processes. And up you can see another way on eco-design approaches. So we have a printed garment, we are adding another layer of new drawings on printing, and we can transform and have different products on this. So this is briefly my presentation. The idea is when we look at a holistic vision on all the processes of the textile value chain, we have always to look at the big picture. It's not only looking at a glass and say it's half empty or half full, because in our vision it's always full, because it's full with water and air. And both water and air, oxygen, are crucial for our life and for our subsistence. So we always need to look at the big picture, and we have to have all these technologies engaged, and to see how we can promote further this innovation in materials. And for sure, if we work in different levels at the same time, we can solve the challenges that the industry is facing currently and that we'll face in the future. And this is it. Thank you for your time. I think I kept the time, so I'm ready to any questions that you want to address me.
Yeah, thank you very much, Carla, for a very interesting presentation. It's really interesting to listen to you and hear about this fantastic project. I'm very impressed of your work. So, and there are some questions in the Q&A, which we can start with. The first one is who is financing this huge program? You might mention it in the beginning, but it's good to repeat.
So this is from the Recovery and Resilience Plan. In all countries in Europe after COVID, there was this program implemented at the European level. And in particular, this is for the Portuguese Recovery and Resilience Plan, so with European funds, of course, but from the Portuguese government, and in particular, this is from the component 12 of the bioeconomy. So Portugal is also having a strong emphasis on the bioeconomy and the circular economy action plan, and they are putting effort to have a bioeconomy supported industries on textile industry, but others. So this is in particular financed by this recovery and resilience plan. But it's important to mention that this project is financing not only R&D activities, but also, and in particular, the majority of the funds are going to innovation capacity. So to implement capacity in Portugal to produce these innovative materials. So we are installing at least 10 innovative processes in different industries, in different partners. So we will have the capacity to produce regenerated cellulosic fibers, the capacity to produce yarns from hemp and linen, the capacity to extract these fibers from these unconventional sources, also to promote the hydrolysis and the treatment of the residues in order they can be transformed into raw materials for the textile industry. So these are some examples of the capacity they've been installed.
Yeah, very, very impressive, as said. And that with upscaling, that was really one of my questions, but I think you already answered it. Someone here is wondering if you can share the presentation afterwards.
Yeah, I can share the presentation, yes.
Yeah, and then we can do it by TEX-BREIN here. The project is very interesting for the natural fibers, for synthetic fibers and composite synthetic natural seems quite challenging. That's a comment from neutral fibers. So good. I'm also a little bit curious about how do you work for all those techniques you are working with? Are you doing any life cycle analysis or so you know where you will end up in the end?
Actually, that was one of the requirements in this financing program. So since it's being financed by our Environment Ministry, we need really to ensure and to validate if we are decreasing the CO2 footprint and if we are having better environmental performance. So for all the products and some of the products, this project aims to develop 55 different products. We have up to now, so the project will end, I forgot to mention, but the project started in 2022. It will end in June next year. And up to now, we have 50 different products already with validated LCAs and LCC. So this is quite crucial for us because we had to make some options and to let some of the process that were quite innovative from the R&D point of view, but if they are not bringing additional environmental benefits, we cannot move forward. So, of course, and also the scaling processes, because that is very important in this project. And we are doing this for all the products that we are developing.
Very good. Let me see. There no more questions here. About these color removal techniques you are using, does that work for all dyeing techniques? For instance, like spun dyed or so? I was thinking of the synthetics there.
Yeah. So we also test with polyester. So with different dyes, so not only for reactive dyes, but also for bad dyes. And depending on what we are seeing, it's not working with all the dyes families, but the majority of the dyes, we can remove the color. We are having differences, for instance, if we are just using one dye or 3 dyes for trichomy, there are some changes. But with suitable adaptations of the methods, we have, and we are publishing a paper on this, that we have used design of experiments to optimize the process, and we can combine increasing temperature or changing slightly the concentration, and we can really achieve the removal of the colors. When is dope dyed, there is a problem. So if the dye is introduced during the melt spinning process for synthetics, that is really a challenge. In that case, we cannot remove color by this process. Okay, that is a limitation.
Yeah, but it's fantastic
to
be able to remove the others. So
the others, which is a majority, as we also know. But for instance, on automotive industry, they use a lot of dope dyeing yarns because it's better on fasteners, light fasteners, and so on. And for dope dyeing, since the color is intrinsically combined with the polymers, we cannot remove without damaging the polymer itself.
Yeah.
Okay.
Excellent. It seems like no more questions, and it's the time is out. So I would like to thank you very much, Carla, for
thank you for the invitation,
joining here, and a very big thank you to the audience. I hope you have liked this seminar. I certainly did, and hope to see you the 24th of October then. So thank you very much, and bye-bye.
Bye. Have a nice day.